4.1. So I'm just going to kind of do a rundown right quick, and somebody let me know if did we get to the insurance question, life insurance? Did we get to that one? Okay. I went over it with 120.
No.
And I don't know if it was this one or not. Okay, so here we are, chapter 6. I told you about the frequency distribution, or what we call the probability distribution. And I'm going to get there in just a second. And there is your probability distribution. Look in your notes and tell me what are the two tests that you need to test a probability distribution? Can somebody tell me what those are? What do you need to test to see?
Between 0 and 1.
Okay. All of the probabilities have to be between 0 and 1.
And they all add up to 1.
And all of them have to add up to 1. Thank you. So that means all of those, so 0.51 and 0.38, that's 0.89, 0.99, and 99 cents plus a penny is $1. And that's how you check. So there shouldn't be any negative numbers, and there shouldn't be any whole numbers. Okay? So that's the test question. Remember, I told you there's 3 questions on the test. 1 is not, 1 is, 2 test questions. 1 is not and 1 is, but usually they give you 1 with a negative, they give you 1 with a whole number, and then they give you 1 like this one. So that's the way they usually do it. It's usually 3 questions. Sometimes it's 2. Okay, so that's 3 test questions you could have right there. And then you've got to find the mean and the standard deviation. Did we cover that? I think we covered that, correct? Did we cover that? Finding the mean and the standard deviation? Yeah. Okay. So I don't think we covered the expected value. There's the test. And okay, there's a negative. So that's 1 test question right there. And then they'll give you 1 that doesn't add up. And there's that one. And then they give you 1 that does. Okay. So there's that. I don't really graph, but you can do that in your calculator or your Excel spreadsheet. I really don't graph. I really don't ask that many questions on graphing because I really don't see the point in graphing a probability distribution, but that's just me. There's graph. I really don't care. There we go. And there is the formula for that. I gave you that. And I think we did a problem with that. But I want you to also write the mean is also the expected value. Write that down. The mean is also the expected value. What's the expected value? Well, that's a term you use in business, especially in life insurance companies or insurance companies. Expected value. It's a 25-cent word for the mean. So I want you to make that note here that the mean is also called, in certain contexts, the expected value. And put life insurance, because that's the question we're going to go over today about life insurance. And this is complete the mean, and I showed you that on the Excel spreadsheet, and I'm not going to go through that. I want to get to the question that was sent to me in this class. Now, this is, what is this? This is the mean. This is how you find the mean of a, test grades. You add them up and you divide by n. That's called the mean. That's called the data-driven mean. The data-driven mean is the true mean. The previous screen, this mean right here is the calculated mean for a probability distribution. This mean will approach the true mean the more numbers you crunch. The more numbers. Remember the law of large numbers? It still applies. Okay? So, with that being said, they're going to have a slide here that says, there it is, the difference between X bar, write this down, because this is in your test questions. One of them Philadelphia lawyer questions that ask you, well, what does it mean? And then they give you 3 choices. And everybody should be writing this down. I don't know why everybody ain't writing. The difference between X bar and the calculated mean is what? It gets closer to 0. The difference, they get closer to each other when N increases, or the number of subjects that you survey, or the number of research that you do gets bigger and bigger. That right there is a test question. Okay, here's a basketball player, throws 100 times, and his mean is 2.35. And we got 2.4 from the previous probability distribution. So you see they're very close to each other. And there we go. So write this question down. You don't have to write down every single word like the National Vital Statistics Report. You don't have to write the footnotes. Just write down the gist of the question. This is a test question, and this is a homework question that was sent to me in this class. Only one person sent one, so that's extraordinary for this class. So a life insurance policy will pay a beneficiary a certain sum of money upon the death of a policyholder. These policies have premiums, payments that must be paid annually. Suppose an 8-year-old male buys a $250,000 life insurance policy for 1 year for $350 for that year. The probability that the male will survive the year is 0.998937. Compute the expected value of this policy to the insurance company. Now I want you to highlight to the insurance company, because this question is by the eyes of the insurance company. So somebody tell me what the $350 is to the insurance company. Would it be positive or negative? Positive, because that's money coming what? In. What if you had to pay $250,000? Would that be a positive to the insurance company or negative? Okay, but it's not going to be 250. In their eyes, it's going to be $249,650 because they got $350 of your money. Now, there's 2 events that are happening with your life insurance. What are they? You either live or you what? You die. So that's your 2 events. What if you live? Well, that's 0.998937. What if you die? That's 0.001063. What is that called? Starts with a C. Huh? Compliment. Thank you. You were the one that listened. Okay? There you go. There's your table. Just like the table we used with the events, 0, 1, 2. In this case, the event is you either die or you what? You live. And there's the probabilities of living and dying. Now you just multiply them and add them up. If you get a positive, that means that the insurance company is making a profit. Write that down. If you get a positive, that means the insurance company is, what is that, a dog? Oh. I'm just looking at the dog. Is that a dog or a pillow? I can't see. Looks like a dog.
It's a dog.
Yeah.
He's not feeling too good, so he's wanting my lap.
Oh, okay. All right, so 350 times 998,937 plus negative 24965 times 0.001063, and that comes out to be $84.25. It could be $8.05. As long as it's positive, that means the company is making a profit. If it's negative, that means the company needs to readjust the premium because they're not making any money. Now, a lot of people say, well, good God, I thought insurance companies make money. They do make money because not a lot of people what? Well, that's right. She's getting it. They don't jump over hay bales rolling down a hill, do they? They don't jump off the house onto a table acting like wrestling. Okay? They don't do stupid stuff. Okay? So most people, try to live. So you take that $84 and you multiply it by 1,000 people. That's $84,000. And what do you have to have in order to drive a car on the road? Money. Insurance. You have to have insurance. Yeah, you got to have money now, especially since we got people being paid, for the OIL from Ukraine and China. Oh, I'm sorry, I shouldn't have said that. You got to have what? Car insurance. We're talking about life insurance. What does everybody have to have if you have a family? You need to have life insurance. Okay? And that's those things that you think about when you get out of high school and you say, oh, I'm going to work at Walmart the rest of my life. Okay? Then you ain't going to have life insurance. Because I was going to be Mr. Walmart when I was in high school. I was going to work at Walmart the rest of my life. Okay? We are a product of our own what? Decisions, choices. You choose, that is such a waste. You choose to go the easy route, not go to college, not learn a trade, and just hang out at Walmart for the rest of your life. Then when you have a family and you don't have life insurance or good medical care, whose fault is that? Your fault. Okay? That's your fault. That's not my fault. It's not anybody else's fault. It's your fault for making that decision. Just like I'm going to give you another example. You hear about all these people fussing about, and what I'm trying to explain something to you here. Okay? You hear all these people about free college, free college, free college. Who decided to go to Harvard and who decided to take out loans on a underwater firefighting degree that you can't get a job in? Who decided to do that? The student. Instead of going to a college that they could afford and getting a degree that gets you a daggum job or a trade that gets you a job. Who makes that decision? You do. Okay? So life insurance is one of those things that you need to think about. When you get out of high school and you say, I need to plan for my future. Life insurance, retirement, and health care. Those are three things that you should think about before you start saying, well, I'm just going to work at Walmart the rest of my life. Okay? All right, next. And that's how you do that. If it's negative, that means it's a loss for the insurance company. Now, I got one question. What if the question said, instead of the insurance company, what if the question said the client? And what would be the change? There'd only be one little change. What's that? Good job. write this down, if the question said the client, then the 350, what's that to the client? If you pay out 350, is that negative or positive? Negative. And what would be the beneficiary? That would be positive, only you wouldn't get it. Somebody else would get it. Unless you fake your own death and then get it somehow. We won't go there. So if the question said the value is negative because money is paid by the insured, okay, well, wasn't it? Back up one. There. If it said compute the expected value of the policy to the client, then you would have negative 350 and positive 249,650. Everybody with me? Okay. And there's the standard deviation. I told you that one is when we went through that. And that's your two test questions that you could have mathematically. Find the mean and standard deviation of a probability distribution, or find the expected value of a life insurance policy. So that's two test questions mathematically out of 6.2 that you 6.1 that you could get. And I'm just going to show you, there's that one, and there is the standard deviation. I'm sorry, there's the standard deviation. You take the square root of the variance to get the standard deviation. Now you're going to use that in chapter 7. So get ready, because chapter 7 is where we're really going to get into the nitty-gritty of the standard deviation and the mean. And let me see if there's anything else that we need to worry about. That's another thing, same thing. I'm going to show you how to do that. Okay, now 6.2. What are we going to do in 6.2? 6.2 is based on the following three letters: N, P, and X. You got note taking on your phone? Yeah, you expect me to believe that?
No.
Okay, just wanted to know if you were just texting while I was talking. That's all I was wanting to know. But what if, let me ask you a question. I'm going to turn it around right quick. What if you came up and asked me a question after class and I started talking to somebody else and started texting while you were asking me a question?
I get why you'd be frustrated.
Okay, just wanted to know. All right, so the binomial and probability distribution, N, P, and X. Write that down, N, P, and X. N is always your largest number. P is always your percentage or your probability. And X is always what if. Let me give you an example. Let's say that I flip a coin 50 times, and you need to write this down. Flip a coin 50 times, and it comes up heads. Probability of heads comes out to be 0.4. What is the probability if I flip the coin 10 more times? N is 50, P is 0.4, X is 10. Write that down. N is 50, P is 0.4, and X is 10. And you would type that in your calculator and get a probability. And that would be the probability that if you flip that coin 10 more times, it's going to hit heads. Okay, that's an example of what you're going to be doing in 6.2. You're also going to find what? The mean and standard deviation of a binomial probability distribution. Now, what's the difference between a binomial probability distribution and a probability distribution. A probability distribution is what we did in 6.1. Write that down. Probability distribution is the table. Probability distribution is the table. You know, X and P of X. A binomial probability distribution is just numbers. 500 people work at BFE company. 150 called in sick, or 35% called in sick. What is the mean? They just give you numbers. They don't give you any table, they just give you numbers. And I'm not going to worry about graphing. All right. I'm going to show you in just a second. Hold on. How do you test to see if a binomial probability experiment is valid? There you go. Write them down. The experiment is performed a fixed number of trials. I flipped the coin 50 times. Fixed number of trials 50 times. The trials are independent. If I flip one coin and if I flip it one time and it goes to heads, does it have the exact probability of hitting tails the next time? Yes. There's nothing infringent on the coin. You're not going to flip that coin and it's going to land on the side. That's not going to happen. For each trial, there are two outcomes. With a coin, it's male or female. With a coin, it's heads or what? Tails. With a birth, it's male or female. The probability of success is fixed for each trial of the experiment. If I flip a coin, it's not going to end up on the edge. It's going to end up on tails or it's going to end up on heads. If you have a baby, I don't care if it's red, yellow, black, or white, it's either going to come out what? Male, or it's going to come out what? Female. Now, there are some cases where you don't, there are people that are born that doesn't have stuff, okay? But that's an outlier, okay? And I think, what do you call those, eunuchs? Aren't they called eunuchs? I'll forget it. What? Oh, I'm sorry. You don't have to write down each word, okay? And plus, I'm not going to throw you a false question on the test. Anything I give you on the test is going to be doable, except for those first three on 6.1. I might throw you one of those. Yes, ma'am.
Wait, at the beginning, you said N, P, and X, what they mean. What do they mean?
N is always your largest number. P is always your probability or your percentage. Usually it's a decimal or a percent or a fraction. And X is always your what if. What if you flip the coin 10 more times? Now you also got to learn you got to go back and learn your at least and at most words. What does that mean? At least and at most. We'll get to that in just a second. Okay, we already talked about that. Q is the complement of P. Write that down. Q is the complement of P. So if a while ago I gave you P is equal to 0.4, what's Q? Good job, 0.6. So 1 minus P. I have been teaching statistics for a lot of years, and I've seen them for the last 20 years, 25 years, call the complement of P, Q. This is the only book that I've ever seen call it 1 minus P. But in all my algebra books, now they're starting to write quadratics like 4 minus 4P plus X squared. And I'm like, who in the hell ever did that before? I've never seen that before, but must be the Tide Pod way of learning. I don't know. It's went to the teachers. I don't know. I've never seen a quadratic written like that, but all the books now are writing them backwards. I've never seen that before. And X denotes the number of successes. What if? X is what if. X always has to be less than what? N. N is always your biggest number. You can't say, well, I flipped a coin 10 times and I got a probability of heads 0.6. What if I flip a coin 50 times? It doesn't work that way. N is always your smallest number. Trying to find, okay, here's one. An experiment in which a basketball player who historically makes 80% of his free throws is asked to shoot 3 free, say that real quick, 3 free throws, and a number of free throws made is recorded. When you throw a free throw, what's the outcome? You're either going to make it or you what? No. So it's binomial. You either make it or you don't. Just like true, false, male, female, 0, 1, whatever you, heads or tails. Binomial. The outcome, there's only 2 outcomes. There are a fixed number of trials. How many is he going to throw? 3. Fixed number of trials. Trials are independent. If he throws up a free throw and misses it, is that going to affect, technically, is that going to affect his next free throw? No, not really. Psychologically it might, but technically it's not going to, because what? He's going to throw the ball up there and it's either going to go in the basket or it's not. There's no outside forces on the basketball, okay? It's either going to go in the basket or it's not. There are 2 possible outcomes. You make it or you miss it. And that is 0.8, so the complement is 0.2. Now these are, this could be a test question. I could ask this on a test, but I usually don't. I usually just ask the mathematics, find this and find that. And there, what is the probability of making 0, 1, 2, or 3? Now that's where you start getting into the at most and at least, and that's going to go into the inequalities. And I'm not going to go through all of these, but I'll go through this one. According to a recent Harris poll, there's P. Somebody tell me what Q is. 0.72, good. Okay, so P is 0.28, Q is 0.72. Chocolate is their favorite flavor ice cream. So your answer is either chocolate or what? Not chocolate. Most of your binomials is going to be either this or not this. Okay? You can't say vanilla because there's also strawberry. There's also whatever, 55 different flavors. So you can't say just vanilla. You have to say not chocolate. There is suppose a simple random sample size of 10 is obtained, and the number of Americans who, okay, there are 10 trials. There's your fixed number of trials. If you pick one person and they like chocolate, is that going to affect the next person that you ask? No. There are 2 possible outcomes, either chocolate or not. and there's probability. So, and this one goes up to 10. Come on, inequalities, where are you? Okay, we're going to go through this one. Now, this one is not a probability experiment in which 3 cards are drawn from a deck without replacement. Remember, without replacement, you put the card in your pocket. So is the math affected? Yes. So this one is blown out of the water at first, because without replacement, anything without replacement is not going to be a binomial. Okay, write this down. Success means that the outcome has what? Occurred. You may be researching DUIs and impact on people dying. Is people dying positive? No. But a positive outcome in your research would be somebody dying from a DUI, hit and run, or wreck, or whatever. So positive doesn't always mean positive. Positive means that something has occurred, or success. Well, this is not what I wanted, but according to the American Cross, 7%, there's your P, of people in the United States have blood type O negative. A simple random sample, size 4, is obtained, and the number of people with X blood is recorded. Construct a probability distribution. And I'm not going to do this. I do not do tree diagrams, because tree diagrams mess people up. So we're not going, this is not a test question. And there it is. Sample space. Remember, this is either, let's see, what was the question? 4. Remember the 4 children? There you go. You can go back to the 4 children and you'll get 16, 4 to the second power, because you either have male or what? Female. This is either what? O negative or what? Not O negative. And you're going to get 16 different outcomes. 1, 2, 2, 4, 6, 8, 10, 12, 14, 16. Male and what? Female with 4 children. Remember, I told you to copy that down and put it in your notes. Put it on the index card. There's the same thing right here. There's your sample space right there. So I'm not going to go through that. And I showed that. Did we create a probability distribution? Yes or no? Did we do that? I don't think we did. I'll have to do that with you. It's not a test question. Yep. We got to do that one. Okay, here we go. Write that down. There is the formula for NPX. Remember I told you NPX was your formula, or your letters? There's the formula. You need to write it down for your information, because I'm going to show you how to do it on your calculator. I'm going to try to show you before time's up, but I don't know. These slides are very detailed, so I don't know if I'll be able to get there or not. I still don't know why they haven't shown the inequalities yet. I'm sorry, what? Yeah, Q, yes, because I've never seen it 1 minus P before. All the formulas I've ever seen, N combination X times P of X times Q to the N minus X. That's what I've always seen. This is the first time I've seen 1 minus P. Evidently, they don't think y'all are smart enough to understand what the complement is, so they put 1 minus P, kind of like, you know, using crayons to draw you a picture. So evidently, they don't think you're smart enough to understand what a complement is. Now, write that equation down, but put for your information, FYI, and that's just in case you see it on a standardized test. There we go, finally. Is this very important? Yes. Should you make an index card out of it? Yes. Will you be tested on it? Yes. There's going to be some probability of at least, probability at most. Now you got to understand what at least is and what at most is. At least means the lowest number is 2. At least 2, that means your lowest number is 2, so that means 2 and above. At most means the biggest number, at most 2, means the biggest number is 2, so that means 2 and what? Below. Is there such thing as a negative household? So most of these, or all of these questions, will be from 0 to infinity. Can you have a negative person? No. Can you have a negative answer? No. Everything in this section is going to be above 0. Fewer than. Fewer than 2. Does that mean we include 2? No. That'd be 1 and 0. Everybody with me? Greater than 2. That would be 3, 4, 5, 6, 7. Do y'all remember inclusive and exclusive? That's what they're trying to get you to remember here. Exclusive and inclusive. Remember those. Exactly. Well, that's self-explanatory. That means just that number, 6. What is the probability of 6? You just type in 6. Here's an example. Somebody tell me what n is. How did you know that? It's the largest number. You listened. Thank you. It's always the largest number. Well, what about 72? 72 is a what? It's a percent. That's P. Change it to 0.72. And what is X? The only number left. 8. What does it say? Exactly. So we're going to go to the handy dandy calculator, and I'm going to show you how to do this. If I can get out of this. Here we go. And we don't have a calculator on here, so I have to pull up the old reliable. I know what time it is. I'm trying to get this 6.2 in, so y'all have enough homework to discourage you over the weekend. Okay, there's that. Now, y'all realize I just took PowerPoint down. So when I bring PowerPoint back up, it's going to do Season of the Witch thing probably. Okay, here is our, all right, I'm going to clear that and write this down. Second, vars, V-A-R-S, means variables. Second vars, and go down to binomial, because that's what we're talking about. Binomial PDF. PDF means precise. PDF, it doesn't mean that in mathematical terms. It means that in Hubertism terms. PDF means precise, exact. Put exact, because this question said exactly 8 or 6. So you would use PDF. Cumulative means adding up everything up to a certain number, and that's CDF. So P is precise, cumulative is adding up. CDF is cumulative. I'll show you how to use that one in just a second, if I have time. So I'm going to use PDF because it said precise, exact. How many trials? That's N, 10. And what was P? 0.72. And what is X? Was it 6 or 8? And that's it. Now, if you have an older type calculator, you need to type it in like that. If you have an old TI-83, you need to hit second bars, CDF, PDF, and you type it in parentheses, 10, comma, 0.72, comma, 8. You got to type it in that order, N, P, and X. If you don't type it in that order, it's not going to do it. And our probability is, write that down, 0.2548. Write that down, 0.2548. PowerPoint comes back up. Oh God, here we go. I'm gonna send it over. I'm not gonna send it. Uh-oh.
Yeah. Frank's taking that double. You walk. I'm not taking that shit.
You said double shot.
No.
Jose did not
No,
say
no,
double
I
shot.
said I already took one at 7:30.
He said he's gonna take that double shot.
Alright, Frank. You take that little double shot, Frank.
No, Frank, please. I have to go to class, Frank, please.
No, you got it, bro.
I don't got it, bro. And this
You just
nigga
ate.
shit ain't working, bro.
You just ate, bro. You just ate. Come on, let's get in. Damn.
Yeah, I'll do it.
What happened, my guy? What happened?